Alright, today we are continuing with the area of triangles, trapezoids, and rhombi. What you're going to need to do, if you want to, you just put the formulas for each one of them right on your paper. Area of a triangle, of course, is 1/2 the base times height. That's one of the formulas for the area of a triangle. Trapezoids, the area will always be 1/2 base 1 plus base 2 times the height. That's the most common formula for the area of a trapezoid. And as far as rhombi are concerned, there's a couple of formulas you could use. You could, since a rhombus is a parallelogram, you could use base times height as long as these are connected by a right angle. But another one that's kind of cool to use is 1/2 diagonal 1 times diagonal 2. So if you have those right there at the top of your paper, all right, you can use that all the way through the assignment. So write those down. Jot those down. All right, so now what we're going to do, we're going to go over here and look at problem number 9. Now, I want you guys to focus on a couple of things right here. Problem number 9, I want you guys to think of it as two triangles like stuck together. I apologize for my poor coloring ability. Sorry, my kindergarten teacher would be very upset with me. All right, but we have two triangles kind of fused together. All right. Oh, I know this is really going to bother some of you. That little piece right there. All right. Watch what happens when I color it. Oh, it makes it like you patch it and it makes it even worse. All right. So we're just going to leave it. You're going to have to deal with it. Sorry. I know it's going to be painful for some of you. All right. All those people with OCD, like, oh, please fill it in with something. Please. Fine, I'll just recolor it. I know, I can't do anything about it. It'll just make it worse.
Don't forget it.
No, I can't. Watch what happens when I erase it. Look what happens.
Oh my
You know what I'm
god.
saying? It just makes it worse. All right, so we have formulas for the area of a triangle. So in the blue one, put area equal 1/2 base times height. And for the green one, put area equal 1/2 base times height. You just need to know what the base is and what the height is. Now, what are the base and the height always connected by? Right angle. So watch this. What does that distance, what would that distance represent? What do you guys think? You could call it the height, all right, but I'm going to call it the base because I feel like it, all right? Because these share, now you can't really rotate it, okay? But if you rotate it, these share the same base right here, all right? I'm going to label this guy as the height of the blue triangle because it forms the right angle right here with the base. And over here, I'm going to call the 3.5 the height of this triangle. And they share a common, I'm just going to write the word base. They share a common base, which happens to be 6 feet. So all we're going to do is put area equals 1/2 the shared base of 6 times the first height, which is a 4. And over here in the green, we're going to write area equals 1/2 the base, which is a 6, times the height, or I'll do it in red. For all those people like, come on, it's the same color. All right, times the height, and this one happens to be a 3.5. All right. So all you have to do is get your graphic calculator out. Now one of these, what's half of 6? Half of 6 is 3. 3 times 4 is 12, but this is going to be 12 feet squared. All right. And then we have half of 6, which is 3. 3 times 3.5, I think that's 10.5. 10.5. All right. So you know what? We won't since you guys clicked away. That's 10.5 feet squared. And all you have to do is add those two guys together. So what's the total area going to be between the two? 22.5 feet squared. That's the combined, That's the combined area. All right? Now, a lot of times they call it the composite area, like you composed of more than just one triangle. All right? So right now, that's what you're doing when you're trying to find the area of the triangles. Just find the base, find the height, right? Multiply them together, take half of it, and that's going to be your area. That's what you're going to do for problems 10. Ooh, it looks very similar right there. And 11. All right? You got a base and you have a height. You got a base and you have a height. So get those done. If you're having a hard time figuring out what the base is and what the height is, just remember, the base and the height are always connected by what? Right angle. So there's the base and the height for number 11. Okay? Now I'm going to switch it up here. This is the base of this triangle, and then this section is the height. Okay? Because you guys see the right angle right there? That's what you're searching for. You're always searching for that 90-degree angle. I'm not going to give you the answer to this one, but there's the base, there's the height, there's the base, there's the height. Yeah, just find the area of this guy, then add the area of this guy, that's your total area. Alright, let me zoom out just a little bit. Alright, problem number 12. It says trapezoid RSTU has an area of 935 square centimeters. Find the height of RSTU. Well, the height is going to be this portion right in there. This one would be call it base 1. Call this base 2. These are interchangeable. It doesn't matter which one you call base 1, base 2. These have two bases. One of the bases always have to be parallel to each other. That's how you know it's a base. The height has to be the distance that is perpendicular to the bases. So we're going to write down the formula for a trapezoid. Area equals 1/2 the sum of base 1 plus base 2 times the height. So you just write down the formula. Once you've written down the formula, then you plug in the numbers that go in the appropriate places. What number do you think I'm going to plug in for A? The area.
935.
There you go, 935. What number am I going to plug in for base 1? 30. Base 2? There you go. And what are we solving for? We're solving for the height, so I'm just going to put H in green. That's what we're solving for. So 935 square centimeters, that stays the same. We have half of, I heard y'all add that together, that's 85. Very good job with it. There we go. Times the height. Now you could take half of 85 if you wanted to, all right? Or you multiply both sides by 2 if you wanted to, you do that. What is half of 85?
42.5.
All right, 42.5 times the height. And then we just divide both sides by 42.5. So 935 divided by 22. So our final answer, 22 centimeters. That's your final answer. No. Area is units squared, okay? Height is just a distance, all right? So distances are always just to the power of 1. Area is always squared because area deals with squares, okay? Like the area of this square would be 1 unit squared. This has 22 centimeters of height, but the area is 935 square centimeters. What's a square centimeter? A centimeter by a centimeter. So you could call it, that was 1 centimeter by 1 centimeter, then this right here would be called 1 centimeter squared. I know that's a horrible split. Now, on this one, what are you trying to find the distance of this time? You're trying to find the distance of what? M to L. That's different, isn't it? Yeah. So right now, do you have the area? You do. It's 7.5. Now I'm not going to solve this one for you, but I will help you set it up. Start with the formula. 1/2 base 1 plus base 2 times the height. What are we plugging in for the area this time? 7.5. Now, it doesn't matter which one you use, okay? You could call this base 1, you could call this base 2. It doesn't matter. So we'll just call this base 1. And then you're going to solve, I'm just going to call it, you're solving for the other base. Just know that whatever this is, that's the... And then for the height, what are you going to plug in? You're going to plug in the number 2, all right? So at this point, what are you going to have to solve for? You're going to have to solve for B. Now, I don't know if some of you saw this. It's kind of cool. See that half? You see the 2? Take half of 2. Those will just cancel each other out. So literally all you have to do is find what number plus 5 is 7.5, and that's your empty number. Here we go. Let's go on the rhombus here. Number 15. It says, if EG is 50 feet, find FH. Now this says a rhombus has an area of 750 square feet. Now I told you there were 2 formulas. Alright, so right now we have 2 different formulas. Alright? Area equals base times height, or area is for recording. Just so you know, we are recording. Yep, that's what we're doing right now. Recording. Still recording. The other formula is 1/2 diagonal 1, diagonal 2. Alright? Now, which one do you think we're going to use on this one if they told us that EG is 50 feet? I heard somebody. That's what? What does EG represent? That represents diagonal. So you know what? I'm just going to call that guy diagonal 1. So I'm going to call that guy. And then it says find FH. I'm going to change colors here. FH. FH is this guy right there. And what does that guy represent? The other diagonal. So I'm going to call him D2. Not R2, D2, just D2. Oh, I know. So 950, wrong problem, my apologies. 750 is the area, but 750, that's the area, is equal to 1/2 diagonal 1 times diagonal 2. Now diagonal 1 is, good. But D1 is 50. D2 is, that's what I want you to find. So good luck. Just all you got to do is just solve for D2. Not R2, D2, just D2. All right, here we go. By the way, what I'd like to do is I'd like to put problem number 17 in your journal. It's the last problem we're doing today, problem number 17. By the way, in case you're wondering what we're trying to solve for, we are going to solve for the area of each shaded region. All right, so right now we're going to solve for the shaded region of number 17. Okay, so do your best to draw that picture in your journal. All right, doesn't have to be perfect. Just try to draw a square. All right, and then draw a circle around it. All right, now right now the shaded region, everybody. The shaded region is this area. I'm not going to shade everything, but that would be considered the shaded region. And we have 1, 2, 3, 4 of them. All right, now if I gave you guys scissors and I gave you this picture. I'm not going to give you scissors, but if I did, Elmer. So if I gave you scissors, you would cut this circle out, and then what would you cut out of the circle? You would cut out the square. So here's what I want you to do. Put area of shaded. Here's the basic concept, okay? Area of shaded is you're going to take the circle, and you're going to take away the square. That's it. You're going to find the area of the circle, and you're going to take away the area of the square. Now, right now, I want you guys to write circle. And what's the formula for the area of every single circle?
5 times 2 or...
No. That's circumference.
No.
There you go. There's your formula. You need to know that. All right. Circle area is equal to pi times the radius squared. Now, what's the area of a square? What do we do with that? It's just the side times itself. So you can say side squared. You can say length times width. You can say base times height. But we're just going to make it easy. Side squared. Now, does anybody know what this 12 right here represents? There you go. That's the radius. Very good. So right now, the area of the circle is going to be pi times 12 squared. Now that's going to give me 144 pi. Now I don't want to know the decimal yet. We're just going to leave it as 144 pi meters squared. That's the area of the circle. Now, everybody? It's okay. That's okay. You can. By the way, if I drew that from there to there, what do you think this distance is? 12 meters. Now, I'm going to shade in something here. This is a special triangle. Oh, it's an isosceles. This side is definitely equal to this side. By the way, how many degrees are right there? 90. How many degrees are right here? Yes, how are you? I'm sorry? I do. All right, she's on her way. Way to save a life. Now, this is a 45, 45, 90. So right, 45, 45, 90, x, radical 2. There we go. You're going to put a 12, and a 12, and a 12, radical 2. Which means this side is 12, radical 2. And this side means this is 12, radical 2. Which means this side is also 12, radical 2. So every single side of the square is 12 radical 2. Now how do you find the area of a square? What do you have to multiply to itself? That's right, 12 radical 2 times 12 radical 2. Now, by the way, 12 times 12 is 144. Radical 2 times radical 2 is just a 2. So you're going to get 288 meters squared if you did that in the calculator. If you don't believe me, that's okay. If you're wondering why I'm rushing, it's because this class is about to end and we need to finish this problem. So I'm going to do 12 radical 2. Press enter. And what am I going to do with this number? I'm going to square it. And look what you get. Because 12 times 12 is 144, and radical 2 times radical 2 is 2, and that's 288. So here's your final answer. You're going in the calculator right now. 144 pi minus a what? 288. Round your answer to the nearest 10. 164.4 meters squared is your final answer. 164.4 meters squared. What does that represent? That represents the area that is shaded. Have a wonderful day.